Oh, darn. So one of the methods that we use when we're solving what we call exponential equations, and basically the reason we call it an exponential equation is because we're solving for the variable that's in the exponent, okay? So one of the strategies that we can use is to get the same base on both sides of the equal sign. And if we have the same base on both sides of the equal sign, then that means we can set the exponents equal to each other. So if I have, on the left side of the equal sign, I have 2 to some power, and then on the right side of the equal sign, I have 2 to some power, then it seems pretty clear that these powers must be equal to each other. If I'm raising 2 to the power of x plus 1, and I say that's equal to 2 to the power of 9, then the x plus 1 must be equal to the 9. So the solution to this equation would be simply x equals 8. Okay. We can easily check that in our calculator. Of course, we know we can just substitute the 8 in there, but sometimes when they get more complicated, it's going to be easier to check it excuse me, by graphing it. So if I want to check this on my calculator by graphing it, in y1, I'm going to put the 2 to the x plus 1. Oops, wow, what in the world happened there? And in y2, I'm going to put 2 to the 9th. Okay. And what am I looking for on the graph? Where they intersect, right. So, excuse me, I do have to adjust the window because I've got 2 to the 9th here. And how high does 2 to the 9th go? What is 2 to the 9th equal to? 512. So I need to adjust my window so that I can see that. Because if I graph it right now, I'm only seeing one of the equations, right? I'm only seeing the blue one. I'm not seeing the red one, which is 2 to the 9th. So what do I have to do to adjust my window? What am I going to change? What's the maximum y value going to do for me? Right? If I graph this, why am I not seeing the red line? How come I'm not seeing 2 to the 9th? Say again? It stops at 10, exactly. The y only goes up to 10. So I need to adjust my window so that I can see that y value of 512. So I'm going to make it 600. And I'll go by increments of 100. Okay. Now I can see both lines, and I'll do a calculate intersection. First curve, second curve, and guess. And there we have, x equals 8. Okay. Now, of course, we know that in this particular problem, it's much quicker to just substitute the 8 in there. But again, we're using a simple example to show you a technique. Okay. Okay. So let's check. Let's do this one. How do I solve this? Gabriella, how do I solve it? Good. 4n plus 5 equals n minus 7. So we get 3n equals negative 12. So n equals negative 4. And there you go. Okay. Of course, they do get a little harder. We don't want to be too bored, right? So number 3, we've got to do a little bit of work here. What do we have to do? What happens when we have the same base and we're multiplying? What do we do with the exponents? Add them. So this is k plus 2. Okay. And again, I'll set my exponents equal to each other. So this is going to be 2k plus 2 equals 5k minus 1. And we'll subtract 2k, so I get 3k. And I'll add 1, so we get 3. So k equals 1. Again, let's check this in our calculator because I want you to get comfortable with your calculator. You've got to get used to using it. So on the left side, I'm going to put 3 to the power of k, so we have to use x obviously, times 3 to the power of x plus 2. And what are we putting in the other line? 3 to the power of 5x minus 1. So I'm going to graph this in a standard window and see if that works. So I go zoom standard. And there's the first line. And there's the second line. That's kind of hard to see, isn't it? What did we get as an answer? 1. Okay, so if x equals 1 is an answer, so here's my x equals 1 right here. So am I correct with my answer? Yeah. Probably intersects higher up, right? If you look, right, x equals 1, I'm not seeing where they intersect, so I need to change my window. And we're going to do the same thing again. We're going to change our y value. I'm just going to make it 200, and I'll go increments of 10. See what that looks like. Okay, now I can see where they intersect. So I'm going to do a calculate intersect. And sure enough, I get x equals 1. Okay? So we can check these on our calculator, but a lot of times we have to adjust the window on our calculator for these exponential equations. Okay, see if you can do number 4 by yourself. Okay, so what are we going to do on number 4? Jordan, what are we doing? Right. So this is going to be 10 to the 5th equals 10 to the 3v minus 7. Okay, so 5 equals 3v minus 7. So we get 12 equals 3v. So v equals 4. Okay? All right. Questions on numbers 1 to 4? Okay, let's look at 5. So we need, actually, you tell me what we need to do. Diana, what do we do?
I don't know. You get to the same base of V6.
Yeah, this is an exponent the variable's in the exponent. So if we can get the same base, we can solve it. So I can definitely rewrite this 36 as 6 to the 2nd. Now I have the same base. So we can say 2x minus 10 equals 2. So again, solving this simple equation. X is equal to 6. Okay? Okay. Morgan, how about number 6?
2p minus 7 and then equals 2 to the 3rd.
Good. Right. So again, I'm trying to get the same base. It's not always going to be possible, but we're going to do that if it is possible. So we have p minus 7 equals 3. So p equals 10. Okay. Moving on. Ava, how about number 7? can I rewrite that 1/7 using a base of 7? 7 to what power? Mika? Yeah, 7 to the -1. Good. Okay. So we've got 4x plus 11 equals -1. So 4x equals -12, which means x equals -3. You okay, Ava?
Yeah, I just thought that if it was to the power of 1, it would be 0.
Right. So basically what we did is we rewrote this as 1/7 to the first, right? And so if we move its position to the top, it makes that a negative exponent. Okay. Okay. Let's see. Alex, how about number 8?
Change 32 to 2 to the 5th.
Good. All right. So we get 14 equals 2m, so m equals 7. These are pretty easy, right? Okay, Allie, how about number 9?
Would you change 27 to 3 to the 3rd?
Good. Excellent. So we're going to change that to 3 to the 3rd, right? So now we have to remember, what do we do when we have the exponent outside the parenthesis? We multiply. So this becomes 3 to the 6x plus 18 equals 3 to the 2x. So I've got 6x plus 18 equals 2x. So I'm going to subtract, and I get -4x. So x equals -18 over 4, or -9 halves. All right? So that's another one. That answer looks a little weird. So I can just do a quick check on my calculator and see if that's correct. Okay. Right, so we have 27 to the 2x plus 6. And of course, you can type it into your calculator a lot faster than I can here. It's 3 to the power of 2x. Okay, and I'll just graph it in a standard window first. Okay. It looks like, so if it was -9 halves, that's -4.5, so right about here. I could zoom and look at that better, but I don't have to. I'll just do calculate intersect right from here. Notice, remember, it defaults for you, first curve, and then I see up the top, it picked the second curve. And a guess, I'm just going to press enter. And sure enough, it gives me the -4.5 as an answer. So I could have zoomed in to see how they cross a little better, but it's not necessary because algebraically I came up with that solution. I just want to check it. Okay, so here we have 4 to the y plus 2, and we're going to change the 16 to 4 squared. Don't forget, we've got to multiply that out. So this is 4 to the 2y minus 6 equals 4 to the y plus 2. Oops. Okay, so y plus 2 equals 2y minus 6. So let's see, I'm going to subtract y, and I'm going to add 6, so I get y equals 8. Okay, getting a little bit harder. Okay, number 11, we have to change both of them. So which base could we use? 5, right. So this is 5 to the third and 5 to the second. So we get 3y equals 2. So y equals 2/3. Okay, I'm going to give you some time to do the remainder of this worksheet. And we'll go over the worksheet and then I'll give you your homework worksheet. Okay. When you finish this, please upload it to Google Classroom. Okay. We're excited. Okay. Let's see, number 12. What base did we use? 2, right. That's got to be base 2. So this is 2 to the 4th times to 3x equals 2 to the 3rd, x plus 2. So we have 12x equals 3x plus 6. So that's 9x equals 6. So x equals 6/9 or 2/3. Good? Okay. You need to be telling me we're not. I'm assuming you're getting it. Okay, number 13, once again, this is one where we can't use a base of 4, so we have to use a base of 2. So 2 to the 2nd to the 3x equals 2 to the 3rd to the x minus 1. So 6x equals 3x minus 3. So 3x equals -3, x equals -1. How are we doing? Give me a fist of 5. Okay, good. You guys are so enthusiastic. It's unbelievable. Right, Alex? Okay, next one, 81. So my clue here is when I look at the 1/3, because there's really only one way of writing that and with one base. So I'm going to rewrite that as 3 to the -1 to the 2x. Well, since I used a base of 3 here, that's my clue that the 81 has to be written as a base of 3. Well, it turns out 81 is 3 to the 4th. Okay. So the 81 was a little tricky, but by looking at the other side, it helped me out. So I've got 3 to the 8x plus 20 equals 3 to the -2x. So 8x plus 20 equals -2x. So I get -10x. So x equals -2. Okay. Questions on that one? Okay, some of you are still struggling with the fractions. Just remember, fractions are going to have negative exponents. Okay, number 15. So again, I cannot use a base of 8. I can't use a base of 4, so I have to go to a base of 2. So 2 to the 3rd. And over here we have 2 to the 5th. So that's going to give us 6a minus 3 equals 10a plus 5. Okay, so let's see. It's going to give me 4a. If I subtract 6a, and if I subtract 5, I get -8. So a equals -2. Okay. We good so far? Okay. 16. This is a tough one. 27 can be written as a power of 3. Excuse me. Oh my goodness. Excuse me. Okay. Where were we? 27 can be written as a power of 3. How about 243? What's that? 3 to the 5th, right. I can't write now because I have sanitizer on my hands. All right, 3 to the 5th. Yeah. To the x minus 2. So that means I've got 6x equals 5x minus 10. Make sure I didn't make a mistake here. Okay, so then I'm going to get x equals negative 10. Good? Everybody's happy as a lark? I don't know why we say that. How do we know larks are happy? Huh?
Is it supposed to be happy as a clam?
Happy as a, why would a clam be happy?
No, it's lark. Yeah.
It's happy as a clam?
I've never heard lark before.
Why would a clam be happy?
Why would a lark be
Happy as a hippo?
You didn't hear that. You didn't hear that. Yeah.
Grant has happy hippos. You guys have happy clams. I have happy larks. I don't know. From the three of them, I think a lark sounds happier than a clam or a hippo.
Yeah.
It's both of them?
Lark and clam. I've heard both.
Yeah. Happy as a lark. I guess because they flight around, but I don't know why clams are happy. Okay. 64. How do we write that? 4 to the... What did you find out?
It's happy as a thing high tide.
Yeah. Because it's like it's implied that it's happy as a clam like when they're at the high tide.
Oh, okay. See the things you learn in math class? See? Okay, so this is, what's the right side of this equation? 4 to the, yes. 4 to the 1 plus 4x. Okay. So we have 3 equals 1 plus 4x. So that's 2 equals 4x. So x equals 1/2. Yeah, larks kind of fly around and like, right? They seem happy. Like, how can you do that without being happy? Like, yeah. Okay, number 18. All right, it's getting harder, right? 9 to the 2x plus 4 plus 2x equals 9 to the what? Negative 2. Good. So we have 4x plus 4 equals negative 2. So 4x equals negative 6. So x equals negative 6 over 4 or negative 3 over 2. There we go. I mean, really, just take a moment to look at your work and like, could you have done this a month ago? Nope. You'd be like, how do you solve in the exponent? You can't do that, but you can. Don't you feel good about that? Doesn't it make you feel happy? It's like, you're going to go home there and say, I learned something in class today, Mom. Your dad won't listen, but your mom will listen because moms, that's their job. They're like, oh, good job. You know, dads are like, yeah, go shovel the backyard. Oh, wait, you don't shovel here. Okay. All right, what do we do? 1/7. What's 1/7? 7 to the negative 1. There we go. And 49, we know is 7 squared. All right, so now we have, this is 7 to the 2x minus 10 times 7 to the x minus 9. I mean, this is some major math going on here. So we get negative 1 equals 2x minus 10 plus x minus 9. So negative 1 equals 3x minus 19. We're going to add 19 to both sides. So we get 18 equals 3x. So x equals 6. Now that gives you a feeling of accomplishment. Yes, ma'am. Oh, you're going whoop, whoop, whoop. There you go. Ariel's doing her little cheer. Okay. Last one, and then I'll give you your homework, and you can do more. Whoop, whoop. Yeah, see? Good job, Mika. All right, we got 4 to the 2x. times 4 to the negative 2 equals 4 to the 6x plus 18. All right, this is 2x minus 2 equals 6x plus 18. So let's see, we're going to subtract 2x and we'll subtract 18. X equals negative 5. All right. Diana, you want to do the next one?
Yes, she does.
The next one?
We're done.
Oh, we're done.
Wake up! Okay, questions. Questions. All right. Here's your homework. Please upload it to Google Classroom. We'll go over these Tuesday. That's okay. Keep it in case you want to practice for your quiz.
We're gonna have a homework quiz on
Both sides. We will have a homework quiz on this, and we have a regular quiz on Wednesday. Okay. Make sure you show your work on it, okay? It's only going to get more and more fun for those of us that love math.